Hello, my name is Praneeth Abburi. I'm a sophomore in the Konow lab, and I'll be presenting how the fascia relates to muscle performance. To start off, the fascia is a connective tissue that surrounds and protects muscle. As you can see, the fascia serves to enclose the muscle fibers in tight-knit compartments, and it's been theorized these compartments might help trap intramuscular pressure, aiding force production. Now, the fascia's connection to muscle performance and pressure carries medical significance. This is because fasciotomies, or the removal of fascia, is a common treatment for compartment syndrome. This syndrome involves pressure building up inside muscles to such an extent that often causes patients a lot of pain. Now, as you can imagine, fasciotomies are incredibly invasive procedures. As such, it's important to quantify what the side effects are. Now, there has been work on this topic in the past. Rudiman et al. Found in their paper that force with respect to length change did decrease between their intact and breached compartments. That being said, some major questions still remain. One such question is how the force velocity and power velocity relationships change. So, we hypothesized there will be differences in the maximum stress, which is merely force normalized by PCSA, or physiological cross-sectional area, velocity, and power between intact and breached compartments. To test this, we used an in situ procedure as visualized on the diagram on the right. As you can see, the sciatic nerve is tied off to attach to a nerve cuff. Furthermore, the distal tibialis anterior is removed from the mouse and attached to a lever motor. And we looked at two groups. One group had the compartment left intact, the other group had the compartment breached. From this, we can then construct our force velocity and power velocity curves, and from these, extract our three variables of interest: maximum stress, maximum power, and finally, maximum velocity. Analyzing our data through a series of box plots, we did first find there were differences in terms of maximum power. As you can see in this plot, the power for the breached compartment is a bit lower than that of the intact compartment. However, we did not find a significant difference in either stress or velocity. This raised some interesting questions, as our data seems to suggest that power, which is force times velocity, is different, while force and velocity themselves are not. However, it should be noted that with this p-value right here, perhaps a few more experiments could reveal a significant difference in stress. All in all, our work suggests that compartment release may affect muscle performance differently than previously thought. Given that the force-velocity trade-off is a key limiter in muscle performance, this could better inform decisions made by medical providers prior to acute surgery. And further, this could also guide future research on how to best rehabilitate patients who receive fasciotomies. Finally, I would like to thank the members of the Konow lab for their support and the folks at the Concord Field Station, as well as UML for organizing this symposium. Thank you all.